Hey folks, how we doing? This is just a little recap of the Unit 3 review activities. And so in this little video, I'm just going to go ahead and go through what is going to be on this assessment in terms of what is on this packet right here. I'll walk through the problems and I'll try to walk through as many of them as I can, depending on the relative difficulty. I may or may not get to all of the ghost pepper problems. But of course, those are questions where if you're still stuck, I really encourage you to reach out to me in person, and I'd be happy to take care of trying to help you with that. All right, so the skills in this packet are going to be writing linear equations in three forms, graphing linear equations, analyzing linear equations, okay? And that includes the graphs and the formulas themselves, parallel and perpendicular lines, solving simple inequalities, compound inequalities, two variables, okay? That's the coordinate plane, including systems and equations and inequalities in context. Okay, so I'm going to dive right into it. All right, I'm going to start with writing linear equations in three forms, okay? So there's two ways that we've talked about these formulas right here. I just would make a note that this is one way we've talked about this form. The other way you might have seen it is written like this: y minus y1 equals m times x minus x1. Okay, they're just two different ways of writing the same thing. Okay, so if we look at this standard form, we know that goes with ax plus by equals c. We know slope-intercept form, hopefully the most familiar, is y equals mx plus b. And this finally one here, either one or the other, right, is point-slope form. Okay? That is something that we really need to know how to do. And if not, and I really encourage you to take a look at some of my other videos about how we would do that. Okay? So in every equation, I always want to see you write an x and a y. For example, in slope-intercept form, we might have y equals 2x minus 1. Notice how there's still a y and an x in that equation, okay? For the second one, we might have y minus 3 equals 2x minus 5, okay? So we always need a place to plug in our x and our y. All right? Finally, in standard form, you need to clear out any fractions by multiplying everything by the least common denominator, okay? Also, some people say, don't forget, some people always say that the a has to be greater than 0. That is, a cannot be a negative number, okay? So not negative, okay? It depends. I personally don't have a problem with it. But you have to, again, ask in class and see what the policy is there. Some people have me for co-taught, and so I've taught it. We've taught it a couple of different ways depending on the class. So just make sure you reach out about that. All right. So how do we use this? So let's take a look. And by the way, notice how I've left some important notes in the packet for you, particularly the slope formula. So suppose a line, okay, passes through 2, 4, and 5, 7. I need to find its slope and then write the equation in all three forms, okay? So let's start with the slope. So to get the slope, I need to find the difference in the y values, 7 minus 4, over the difference in the x values, 5 minus 2, okay? So what that's going to give me is 3 over 3, or in other words, a slope of 1. And you can see here, 2, I go up by 3, 4, I go up by 3, 7. Okay, so it's a slope of 1. Point slope form could look two different ways, okay? You could have y minus 4 equals 1 times x minus 2, okay? Or you could have y minus 7 equals 1x minus 5, okay? So you could have one or the other. You'd only have to show me one on the quiz or the test because they're both equivalent. Now, to get slope-intercept form, I have a couple options. I could convert one of these into slope-intercept form by distributing. So distributing the 1 and the negative 2 and moving over. Okay, so let's see what happens if I do that. Y minus 4, and I'll use the first one. So I distribute the 1, okay, and I get y minus 4 equals x minus 2. I bring the 4 over by adding it on both sides, and I get y equals x plus 2. Alternatively, I could solve for b as follows. So I start with y equals 1x plus b, and I take one of my points and I plug the y in where I see y, and I plug the x in where I see x. Okay? And I do 1 times 2, which is 2. Then I subtract 2 on both sides, and I get b equals 2. And I come up and I write y equals 1x plus 2. Now, if you write 1x or just leave it as x, those are mathematically equivalent. I would take either one. Finally, standard form. Standard form, we're going to start with slope-intercept form. And what we're going to do is, well, standard form is mainly just slope-intercept form, except what I do is I take the x's and I put them on the same side as the y's. So see what I did there? I took the formula and I subtract x from both sides of the equation. Now, technically, you're not supposed to have a negative sign in front of the x. X is supposed to be positive. So some would argue you're supposed to multiply everything by -1. Okay, I'm actually fine with you leaving it like this, depending on the class. So I've taught it a couple different ways now. So if I multiply both sides by 1, I get this would become an x, because -1 times -1. This would become a minus y, and this would become a minus 2. And again, they're mathematically equivalent to one another. It's just a matter of how you present it is all. All right, now I'm going to move down and take a look at this next one. This one's a little bit more difficult. Suppose a line passes through -2, 0, and 4, 3. We need to find the slope, and again, write the equation in all three forms. So again, I'll start with my slope. 3 minus 0. Be careful on the second one. That's why this one is a habanero, because you need to do 4 minus -2. Okay, and make sure that you get minusing a negative becoming a positive and then converting to 1/2. Okay, that's important. Now over here, we're ready to do point slope form. I'm going to choose 4, 3. Okay, so I'll get y minus 3 equals 1/2 x minus 4. Okay, alternatively, you could do y minus 0 equals 1/2 x plus 2, remembering that you're going to get a plus if this is a minus, or rather a negative coordinate. All right, now I'm ready to do the slope-intercept form. Don't be fooled. This is not a y-intercept. It's an x, or rather, it's an x-intercept because y is 0. So you can't just plug in -2 there. So I'll show you the method we used up here. So I know that y equals 1/2 x plus b. And I'm going to plug in 4. So I know that when x is 4, y is 3. So now I do this math. I get 3 equals 1/2, or rather, that's gone, so that becomes a 2. So it's a 2 plus b, which means that b is equal to 1. So my formula is y equals 1/2 x plus 1. Okay? And we can see out here, because a half of -2 is -1, plus 1 is 0. A half of 4 is 2, plus 1 is 3. Now, for the standard form, I subtract the -1x on both sides. And now I've got a dual issue. I've got a negative and a fraction. So I'm going to multiply both sides by -2, negative to make this positive, and 2 to cancel the fraction. So I get x minus 2y equals -2. Again, for me personally, depending again on how it's been emphasized in class, I generally care more about the fraction being gone than the negative. But I'm going to tell you something. On the first batch of quizzes that I've graded this year for Course 1 Honors, too often were fractions left in standard form. There was a really tragic case of lost points Don't let that be you. Don't let that be the reason that you lose unnecessary points. Okay? Last question in this category. Line bikes are hitting the streets by storm. With a student membership, you pay $1 to unlock the bike and $1.50 per hour to ride. Write a function that gives the cost of the bike if it's rented for H hours. So if we think about this, I'm going to pay $1 no matter how many hours I ride. So if I ride 0 hours, if I just like literally unlock it and lock it, $1. If I ride it for 1 hour, $1. If I go on some kind of marathon and ride my bike for like 12 straight hours, it's still $1 to unlock the bike. That is the y-intercept. Now, what's going to change is the cost per hour. So if I ride the bike for 1 hour, it's $1.50 for the riding, not including the $1 to unlock. Okay, 2 hours would be $3. 3 hours would be $4.50. 10 hours would be $15. So to find that piece of it, I'm going to do 1.50, and then to get the total cost, I'm going to add it up. Okay, that's how I write the function. So you're just literally picking apart the context and you're writing the rule. All right, so if any of this was tough for you, I really recommend you go back before we move on to the next part. Maybe rewind back to a part that you think is a part where you want to recap. And otherwise, we're going to move on in just a second. All right, so I'm going to go ahead and move to the next piece. Graphing linear equations. So I'm given this equation, 3x plus 2y is 12, and I'm going to show why 2, 3 is on the graph and 0, 5 is not. One of the really big concepts that we're going to talk about this year is, all right, that the graph of an equation is all of the points that when you plug in the x for x and the y for y, it makes both sides of the equation equal to one another. In other words, if I plug in 2 where I see x, because this is the x coordinate, and I plug in 3 where I see y because it's the y coordinate, if both sides of the equation end up equal, it's on the line. It's on that graph. But otherwise, it's not, okay? This is going to come back when we talk about functions. So let's show why that works. So if I take 3, so here's my skeleton. So if I plug in an x and a y, if both sides are true, it's on the graph. If not, then it is not on the graph. Okay, so here's my skeleton. And now what I'm going to do is I'm going to plug in, all right, I'm going to see what happens. So I'm tasked with plugging in the point 2, 3. So here I go. I'm going to plug in 2 for x, 3 for y. So I do my 3 times 2, I get 6. I do my 2 times 3, I get 6. And 6 plus 6 is equal to 12. And 12 is equal to 12. So that point, 2, 3, is a combination that makes both sides of the equation equal to one another. So it's on the graph. Let's see what happens if I set up another skeleton. Here's my skeleton. And now into my skeleton, I'm going to plug 0, 5. Let's see what happens. So first of all, this cancels out. Anything times 0 is 0. 2 times 5 becomes 10. And is 10 equal to 12? No, it's not. So what that shows me is that this point, 0, 5, is not on the graph, okay? And so now what I'm going to do is I'm going to try to use that idea to find a bunch of points. What you can see here is that I've already started to graph this out by plugging in a number of points. Now, 3, 7, I chose 3, 7 because it actually doesn't help you make the graph. You can see that 3, 7 is not on this coordinate plane. I chose it intentionally so you could see how it works. The idea of plugging in 3, multiplying by 3, right? This is just me plugging into the skeleton. So the point I always recommend you try to plug in is 0, because 0 is a really easy number to plug in, right? If I plug in 0, I get 3 times 0 is 0, and all that's left is -2, right? That's the y-intercepts. And so the idea is you're not going to be a hero. You're going to choose whichever points make it the easiest for you, okay? Especially if you know you only need 2 of them. Now let's plug in 1. Let's see what 1 looks like. So off to the side, y equals 3 times 1 minus 2, right? If I plug in 1, now whatever I get, that's what's going to be on there, right? So 3 times 1 is 3. And 3 minus 2, that is 1. So 1, 1 is a point on the line. Finally, how about we do negative 1? So y equals 3 times negative 1 minus 2. Okay, 3 times negative 1, that's negative 3. And that is negative 5, okay? All right, so here's what I get. I get negative 1, negative 5. I get, let's see, 1, 2, 3, 1. And so what we see is one of the consequences of this is that we can see that the slope is up 1 over 1. And so the idea is to give you a sense of thinking about plugging in. This is going to be vitally important because as we go forward, the functions we're going to spend the rest of the year looking at, many of the really beautiful, nice ones like quadratics, exponentials, they're not going to follow a constant slope kind of pattern. And so we're going to have to be really comfortable with setting up a table and plugging in some numbers that might not be easy to plug into, okay? And just plugging in and plugging in and plugging in and generating a graph based on that. Okay, now I'm going to go on to graphing in standard form. Now, this is one where we really struggled a lot. So we really have to make sure that we are solid with graphing in standard form. I saw a lot on the most recent quiz of really big time struggles, especially with graphing inequalities. And so remember what I said, if this is an inequality with standard form, if you can't graph the inequality, you can't get the boundary line. If you can't get the boundary line, you can't graph the inequality. So let's get started. This one I'm going to start by finding my intercepts, okay, and see if I can get those on the graph. So first I plug in 0 for x, and then I plug in 0 for y. If I plug in 0 for x, right, what I get is 2y is equal to 20, because this stuff goes away. And that means y is equal to 10, because 2 times 10 is 20. Similarly, if I cover up, let's see if I can roll my finger there. If I cover up, maybe my pinky, nope. Anyway, if I cover up the y, that's like making y 0, 4x equals 20, so x is 5. Now let's see which of these points I can fit on. Well, here we go. I got 5, 0. 0, 10 I'm not going to be able to fit. It's all right. Let's see if I can try to find a different combination of numbers that works. Well, observe that 4 times 4 is equal to 16. I'm going to choose 4. There's a few different numbers you could choose. You could choose 3 as well. So what if we chose 4? Well, 4 times 4 is 16. And notice, once I plug in a number, well, look, now I have the variable all by itself. So that means if I subtract 16 from both sides, 2y is equal to 4, so y is equal to 2. Okay, similarly, if x was equal to 3, that would be 12, and then 12 plus 8 is 20, okay, so y would be equal to 4. So let's take a look and plug a couple points in there, 4, 2, 3, 4, okay, and then you can see if I went 6, 8, 10, I'd be back at 10. So I'll turn my graph, I'll connect. But the idea is, guys, sometimes you're going to not be able to fit all the points on a graph. That's an important skill. And I might be like, look, I'm not going to extend the graph. Tough cookies. You're going to have to find another way to work with that. Finally, let's take a look at point-slope form. Point-slope form is one of the hardest ones to graph, so let's go ahead and break this down. Remember, we have our m, and our m is always the number next to the x value in the right outside those parentheses. And now what I've got is I've got 4 and 3. So the point it passes through is 4, 3. Two ways to think about this. One, if this is a negative 4, then this will be the opposite. If this is a negative 3 or a minus 3, this will be the opposite. Other way to think about it is let's take a look at what happens when I plug in 4, 3. So I'd get 3 minus 3 equals 2 times 4 minus 4. Well, what's 4 minus 4? Well, that's 0. And what's 3 minus 3? That's also 0. So notice how you get the equation 0 equals 0. which is true. Okay, so what that shows you is using the logic that we just used, that shows you that because 4, 3 makes both sides of the equation 0 and therefore equal, it must be the point on the line. So here's the point we were given. I'll make it nice and big. And then using the 2, we get the slope. All right, but you can always make a table. In fact, I really highly recommend you get in the habit of making that. All right, so again, if you need a second to go back and look through anything, I strongly encourage you to take a moment to rewind the video. Otherwise, in a couple seconds, I will move on to the next topic. All right, so let's take a look at the next topic, and that is analyzing linear equations, okay, graphs, and really, if we think about it, formulas. Okay, so remember, the formula for slope is m. Remember, m is the letter we use, and remember, we're going to generally assume it's through 2 points, x1, y1, x2, y2. Someone really smartly pointed out today that slope is rise over run. Very astute. So 2 ways to calculate rise over run. 1, y2 minus y1. Remember, the rise is the y's. x2 minus x1. However, you could calculate it as y1 minus y2 over x1 minus x2. The important thing to notice is 1, y's on top. 2, observe how the 1's are stacked on top of each other, as are the 2's. So as long as you keep things nice consistent, and the y's are on top, okay, you have a little bit of freedom. Okay, now an x-intercept is a point where y equals 0, okay, and let's draw this. Here's my little graph. Here's a y-intercept. X is equal to 0, and here's an x-intercept, right? There's my y and my x, and that is where y is 0. So let's fix that. A y-intercept is a point where x equals 0, and x-intercept is a point where y equals 0. Okay? So let's see if we can find that now on these 3 right here. So remember, with the standard form, first I'm going to get my x-int. So that's going to be y equals 0. Cover up. 5 times what equals 10? 2. Now I do my y-int. I plug in 0 for x. 2 times what equals 10? That's 5. And now I'm going to calculate my slope. 5 minus 0 over 0 minus 2. And that's 5 over negative 2. In other words, negative 2.5. That could be one way to look at it. Or 5 negative 2. Or negative 5, 2. So a few different ways to look at 5 halves. Now let's come over here. So this is slope-intercept form. So I know my y-int is actually 0, negative 4. The big thing is, notice that intercepts are 2 points. I don't want to hear the intercept is negative 4. That's not going to work because, one, if you say the intercept is negative 4, technically you haven't specified which one. Is it you were talking the x-intercept or the y-intercept, and that alone is troublesome because then even if I was going to say, all right, well, technically you haven't specified the both coordinates, if you don't even specify the intercept, I can't even guess which one is which, right? If you say the x-intercept's 4, well, then that tells me that I'm looking at the x-intercept is negative 4. That means I'm looking at negative 4, 0. But if you say the y-intercept is negative 4, I'm looking at 0, negative 4. So to be safe, you need to tell me what intercept and both coordinates. I will not give you full credit without both coordinates. It's a location. The slope, we got the slope right off the jump. That's given to us. The slope is 2. Remember, you never have x in your slope. And now I want to get my x-intercept. So to get the x-intercept, I set it equal to 0 for y. I'm going to add the 4 on both sides because all I'm doing is solving for x. Okay, so I get x is equal to 2. So I get my x-intercept of 2, 0. Okay. Now I'm going to head down to the next one. Write the equation in all 3 forms for the line in the graph. So I've got a little line here. and I know a girl named HB who would not be my friend because I'm missing my arrows, okay? And now that I've made fun of her for that this many times by now, she never forgets her arrows because I've made sure that I've called her out enough so she remembers her arrows. So let's go ahead and see if we can figure this out. Now this graph is a little bit strange, right? Because it's hard to find all the info we need on this graph. I'll admit it's not the most nicely printed graph. So let's see what we can figure out here. Okay, so first I know that I have an intercept of 1. All right, what else can I figure out? So I'm going to take a careful look at the grid here, and you guys might want to pull this grid a little bit closer to your head. So this is interesting. Let's say I want to follow this order, and I want to go point slope first. Well, it's going to be difficult if you don't know the slope. So here's what we're going to do. Let's go ahead and take a look. Let's say this is 3, -1. And this appears to be -3, 3. So that would be down 2 over 3, down 2. So that seems to be pretty consistent. So what we're getting, folks, is we're getting a slope that appears to be down by 2 and over by 3. So that would make an m equal to -2/3 down 2 over 3. Okay, and that kind of makes sense. This graph is a little bit shallower than the graph of y equals x or y equals -x, which is a slope of 1 or -1 respectively. Okay, and so now what I'm going to do is this. I'm going to go ahead, I'm going to jump in, and now what I'm going to do is I'm going to write, now this implies a form like slope-intercept form, etc. I don't think it really matters which order you do it in. Okay, so I'm going to go ahead and I'm going to do it like this, okay? So I'm going to go ahead and start with y is equal to, how about I do -2/3 x plus 1, okay? That's my first form. Now I'm going to go to the second part, and I'm going to do, I might as well do standard form at this point. I'm going out of order, and it doesn't really necessarily matter what order you follow. So I'm just going to do me on this one. So to do standard form, remember, so this is slope-intercept. Remember, for standard, you're going to add on both sides 2/3, okay, x. And then I'm going to multiply through by 3 to get rid of the fraction. So I have 2x plus 3y equals 3. Finally, point slope. Well, now I've identified a couple points here. You could use the y-intercept if you wanted. You could also use -3, 3. Okay, that would be doable. So I'll use the y-intercept because I already have that, and that's more clearly a point. So I've got y minus 1 equals -2/3 x minus 0. I would take that, for example. Anything as long as it's a definite point on the line and you're using the correct slope. Okay, finally, I'm going to go ahead and do the inequality. Now, this one, the inequality did not print out clearly. So I'm going to assume the inequality is shaded on this side of the graph. Okay, you might want to make that adjustment too. So let's take a look here. Notice, let's take a close look at the graph. Okay, notice I found 1, 2 real nice points in the graph. So it's a slope of 1 up 3 over 1. So I've got my y, and at this point it doesn't matter. Remember, you can use any form, so it doesn't matter what form we write it in. Slope-intercept form appears to be the easiest way to get that equation done. So 3x minus 1. Now, I know that I've got to figure out which way does the inequality point. And remember, we're never going to be a hero. We're going to choose 0, 0. And 0, 0 should not make this inequality true. and that's because it's not shaded. So if I plug in 0, what I get is I get 0, -1. That's what happens when I plug in 0, 0. Okay? So I need to choose the equation the inequality rather, that's false. So is this false or is this false? Because again, if this is not shaded on this side, that means this inequality needs to be false. So I need to choose the false equation, and this is the false equation. So I'm going to drop my negative in there. Do I add an or equal? I do not, because this is a dotted line. Okay? So folks, that's all for this particular section of the packet. Go ahead, if you need to, go back and take a look at anything. And if you've got any questions, that might be a time to review any part of this page. And then in a couple seconds, I'm going to move on to the next page. All right, so moving on down, we're at parallel and perpendicular lines, okay? Wow, time flies and you have fun here, okay? So we're already on to about halfway through this packet. So let's take a look. So, what do we know about parallel and perpendicular lines? What we know is that parallel lines have the same slope, and technically they have different y-intercepts. Okay, so keep that in mind. Perpendicular lines have opposite reciprocal slopes. For example, 2 goes to -1/2. Okay, so I'll give you a formula here. Y equals 2x minus 1. Okay? How about y equals 3x minus 1? Here's a parallel line. A parallel line, y equals 3x plus 2. Same slope, different y-intercepts. Perpendicular, y equals -1/3 x plus 10. Opposite, from positive to negative. Reciprocal, flip it around. Okay, that's going to be perpendicular. Okay, now I'm going to do an equation. So find the slope of the line parallel to this, okay, and perpendicular. So all we're doing is finding the slope. Okay, that's all we're doing. This one's going to be parallel. So first, let's identify the slope. Slope's a half. Parallel means the slope is the same. So the slope of the parallel line, 1/2. Perpendicular, here the slope is -1/3. So I take -1/3, I get the opposite. Then I take the reciprocal, it goes to 3. So m is equal to 3. Okay? So we have the same slope, opposite reciprocal. Now I'm going to find the habanero. Now the habanero, I'm going to tell you right now in advance, there is more than one possible answer here. I'm going to give you one possible answer, okay? If you don't get the same answer as me, that's okay. I'm going to have mine go through 5, 10. Whenever you're writing parallel lines and perpendicular lines, my number one piece of advice, and I didn't learn it this way as a kid, but I realized very quickly, and I apologize for any shaking there, let's try to stabilize that. I learned very quickly that point slope form is the best way to do this. So I'm going to have it go through 5, 10. Again, if I say a line perpendicular, that means you can do whatever point you want. So first of all, or a line parallel or a line perpendicular. So first I identify my slope. It's 3/4. So let's identify our slope. And now it's going to go through 5, 10. So y minus 10 equals 3/4 x minus 5. So it goes through 5, 10, same slope. How about this one? So the slope, the original slope is 3. So it goes to the reciprocal and then goes to the opposite reciprocal. So I get y minus 10 is equal to -1/3 x minus 5. Okay? Opposite reciprocal makes it perpendicular. And in this case, I had to go through 5, 10. Remember, in this instance, 5, 10 was my personal choice. You do not have to have it go through 5, 10, but you may have it go through 5, 10. All right. Now I'm going to come down to the equation of a line parallel that goes through 1, 1. All right. Sorry about that. So, find the equation of a line parallel to this that goes through. So this only has one answer, and the reason is this has to go through a particular point. So remember, first we go parallel. The slope is 3/4. Now it's got to go through 1, 1. So I've got y minus 1 equals 3/4 x minus 1. I do it in point slope because then you're not solving for b anymore. You're just trying to get it to go through 1, 1. Perfect. Leave it in point slope. Now, I'm going to do the next one. Again, from the previous problem, we already know that the slope is going to be negative 1/3. If you didn't see how we did that, I recommend you go back and take a look at it. So I'll get y plus 6 because it's minus negative 6 equals negative 1/3 x minus 3, okay? So parallel and perpendicular is not easy. The big thing we have to take out of it, parallel lines, same slope, perpendicular, opposite reciprocal, okay? Remembering point slope is the best way to write an equation in a jiffy in this case. And remembering that you got to really be careful about the slopes here. That's going to make a big difference. Right, so if you need to take a second and go back and look through it, I encourage you to do that. And then in a second, I'm going to move on to the next part of this packet. All right, here we go. The next part of the packet, solving linear equations, inequalities, simple ones. So for each inequality, I'm going to find 2 values that make it true, 2 values that make it false, okay? So when I say true, that means if I plug in x, okay, this whole statement, when I evaluate it, is going to be true. So let's say I plug in 0, okay? Well, if I plug in 0, I get 3 times 0 is 0, minus 4 is negative 4, right? And I know that negative 4 is less than or equal to 5. What if I plug in 1? So 3 times 1 is 3. Minus 4 is negative 1, and that is also less than or equal to 5. Here's a couple that aren't true. What about 5? 3 times 5 is 15. 15 minus 4 is 11, but 11 is greater than 5. And how about 10? 3 times 10 is 30. 30 minus 4 is 26, and 26 is greater than 5. So that's not true. How about this other one? Negative 4x plus 7 is greater than 3. So you remember my big thing, plugging in 0, making this easy for us. Because 7 is bigger than 3. We can see that right away. Negative 1 is another good number, right? Because negative 1 times 4 is positive 4. Negative 1 times negative 4 is positive 4. 4 plus 7 is 11. 11 is more than 3, so those are true. Now I'm going to try 5 again. I love 5. So 5 times negative 4 is negative 20. Negative 20 plus 7 is negative 13. And though 13 is a bigger number than 3, it actually is smaller when it's negative 13, okay? And now let me do, how about 2? Okay, 2 times negative 4 is negative 8, plus 7 is negative 1, and negative 1 is not more than 3. So if I look at my graphs, right, the numbers like 0 and 1, when I graph these, need to be shaded if I was going to graph those, okay? Now I'm going to show you how do we solve and graph simple inequalities. Okay, this is a little refresher. Remember, when you graph inequalities and solve them, it's exactly the same as solving an equation, a simple one. The only difference is, remember, when you multiply or divide by a negative number, you need to change the direction of the inequality. So let's go and try this. So first, I'm going to subtract 9 on both sides, and I get 2x is greater than negative 2. I divide by 2 on both sides, and I get x is more than negative 1. Okay, even though this is a negative, the number I divided by was not negative. How about this next one? 3 minus 2x is greater than or equal to 1. So first I minus 3 minus 3. I get negative 2x is greater than or equal to negative 2. I divide by negative 2, and see, I divided by a negative. So what happens is, okay, I reverse directions. The inequality changes directions because I divided by a negative number. And this goes down and it cancels to 1, okay? And notice if I plug in 1 into this original one, 3 minus 2 is equal to 1, right? Now, if I plug in 2, notice that 3 minus 4 is not greater than or equal to 1, right? So we can see that if I don't flip the inequality, I'm going to be in trouble there. Now I do a closed dot. Remember in the Sophia H rule, more ink to fill in a dot, more ink to write or equal to, okay? Okay, now I did make a mistake that I want to point out. Be very careful here. This is actually more than or equal to negative 1, not positive 1. Okay, so just make note of that. I didn't see that at first. So hopefully I make a note in the video. All right, next one. Solve the inequality and graph. So the only thing that makes this tougher is that there's just variables on both sides. Otherwise, it's basically the same idea. Again, remembering that you flip the direction if you divide or multiply by a negative number. Okay, so here I like to stay positive. I'm going to minus 5x, okay? And I'm going to add 12 minus 5x. So that becomes 20 is more than 2x. It's going to be challenging, right? So I'm going to have to redo these numbers, and that's cool. But let's just make sure I'm right. So I add the 12. This becomes 20. I subtract the 5. That becomes 2. So 10. So x is less than 10. So I'll keep that as 0. But how do we go 2, 4, 6, 8, 10? I'll stick my 10 down here, and I'll extend it. I'll tell you, on the quiz or the test, don't worry about it. I'm going to make sure the number lines are 100% good. Okay, x is less than 10. So we do like that, okay? Next, I'm going to do this next one down here. I'm going to do 175x minus 90. And again, my idea is that I always want to stay positive. I'd rather keep my numbers positive if I can. So 65 minus 175, that's 110. Right? Because I got 175, and I'll show you why. Over here, 175 minus 65, that's 0. That's 1. Now, okay, now I'm going to add 90 on both sides. 90 plus 90, that is, well, 300 minus 90 would be 210. So it is negative 210. Alrighty. And don't forget to put your x next to the 110. And this kind of be a funky number, right? And that's all right. I don't know what kind of fractions you'll be expected to see, but probably one that's not this challenging. So this would be 1, because it goes in so x is less than or equal to 1. It goes in a whole number of times. And remember, this is a negative number, so it's a negative 1. And let's see. Almost like 100 110s. So, and the reason I do 100 is because you can get 110 into 210 one time with 100 left over. So it's going to be like almost 2. It's going to be up and touching 2, but not close. Not actually touching the 2. And then I'm going to be going to the left. So don't get hung up on that one. That one's harder than what you're going to have to do, but you should be able to do a couple things. You should be able to get an x alone in an inequality, knowing that it's the same idea as an equation, but remembering that if you divide or multiply by a negative number, you're going to change the sign of the inequality, rather the way it's facing. Okay, so if you need a second to go back and look through that, go ahead. Otherwise, in a couple seconds, I'll move on to the next section. Alrighty, so now I'm going to do solving compound inequalities, okay? And we're really making it through, right? We're plowing through this one. I'm just going to do a little check, and it looks like, hey, only 2 more sections. We're doing great. So in class, remember I talked about 2 types of compound inequalities, all right? I talked about ands and I talked about ors, okay? The and graphs are ones where you're going to shade in between, okay? And between. So this one would be -4 is less than x is less than or equal to 3. Remembering that the or equal makes it closed, the not or equal makes it open. Okay, on the other hand, let's say I did this. This would be x is less than or equal to -4, less left. Or x is greater than 3. So or, remember, or outside, or shading outside the dots, less left. And remember, we got to use or to be like, all right, x could be less than or equal to 4, or x could be greater than 3. Can't be in between. Notice 0 is not less than -4, and 0 is not 3, so 0 can't make this true. Remember, the idea of a test point still works here. Okay, so let's try to solve some of these. So remember how we solved. These are and inequalities. Let's see if we can solve these. So remember, with an and inequality, you're going to do the same thing to all 3 parts. So the idea is start at x. How would I solve for x? Well, to get x alone, I'd have to add 10. The only difference is when you add 10 here, you add 10 on the left and the right. So I get 25 is less than x is less than or equal to 28, okay? Down here, similar thing. So again, think about what I'd have to do to get x alone. What would I do? Well, first I have to add 4, and then I'd have to divide by 3 if this was an equation, right? So let's see what that looks like. First I add 4, add 4, add 4. I get 21 is less than, or rather I guess is greater than 3x, which is greater than 12. Divide by 3, divide by 3, divide by 3. I get 4 is less than x is less than 7. The flipping of the inequality rule still applies. So for example, if 3 had been negative, I would have had to turn both inequalities the other way and rewrite. And I guess I got lucky in this case that did not happen. But don't forget about the flipping of the inequality signs. That's extremely important. All right, so now I'm going to go ahead and move down to the next one. This is an or inequality. So the or, I'm going to solve one piece at a time. First, I'm going to divide this by 3 and this by 3. So I get 5 is greater than x. In other words, x is less than 5. Then I'm going to solve this one. I bet I come up here, 5x plus 2 is equal to 29. So I subtract. Okay, I get 5x is less than or equal to 27. Divide by 5, divide by 5. X is less than or equal to 5 2/5, or 5.4. So I get x is, and we got to be careful here. Yeah, this is a weird one, right? Because x is it's facing away from x in both of them. All right, no big deal. So x is also less than or equal to 5.4. That'd be a funky graph here. What about the next one? Let's take a look. Okay, so this one's going to require some flipping, but that's going to actually be okay. All right, so here, first, add 5, I'd get -2x is less than or equal to 18. Divide by -2, divide by -2. I get x is greater than or equal to -9. Okay, over here, -8, I get 7x is greater than 49. Divide by 7, divide by 7. I get or x is greater than 7. So again, a kind of funky inequality. X is more than or equal to -9, or x is greater than 7. It's really the same thing as x is more than or equal to -9. Okay, I'm not going to say that these are going to be the same on the test. I would say on the test you're going to get something a little bit less funky than this. But the idea is to think about with or, you're splitting it up and solving it one at a time. And you're knocking the pieces out. Let me show you a little compound inequality with flipping, and I'll show you how this would work. So again, it's an and inequality. So I'm going to be like, all right, what's going to get negative 2x plus 1 alone? What we're going to do is we're going to minus 1 on all three sides. Now I'm going to divide everything by negative 2. But when you divide by negative 2, the sign flips. So 2 is now greater, because negative 4 divided by negative 2 is 2, than x, which is greater than, like, I don't know, 3.5. Now, this is an interesting one, all right? And this needs to be a negative 3.5. When you're done, you need to flip it around, so because I always want to see it going from least to greatest. So that's what you would do there. So I'm not going to promise you're going to see something like this come up, but you do need to know how to adapt here when you have multiple inequalities or like a compound inequality and you're facing a down a negative. Okay, so go ahead and quickly review this, and if you need to go back and kind of look through it, go ahead, and then in a second I'll move on to the next problem set. All right, so now I'm going to go on to our second to last problem set, two variable linear inequalities. Now, I made a whole video on how to graph systems here, so I really need you to work with me, and I need you to help me really kind of master this as we close out the unit. So in this first part, I'm going to choose a few pairs that make each true and a few pairs that make each false, okay? So let's look at this first one. I've got 2x plus 5y is less than 20. So we know that 1, 2 makes it true because 1, we're given it, but also 1 times 2 is 2, 5 times 2 is 10, 2 plus 10 is 12, which is less than 20. 0, 0, definitely true. And in fact, if I come over here, I also get 0, 0 because 0 is less than or equal to 5. But 0, 0 makes this false because 0 is not greater than 4. And 0, 0 makes this false because 0 is not more than or equal to 7. All right, let's take a look at another one that could make it true. We have a lot of options. I'm going to choose 1, 1. I like nice, easy test points. Why do I know 1, 1 makes it true? Because 2 plus 5 is what you get when you plug in 1, 1. And if you think about it, 1, 1's value is going to be less than 1, 2. You're going to get a smaller number if you add 5 once than if you add it twice. So if this made it true, then an even smaller number is also going to make it true. What about some false points? I'll choose 210. That's 4 plus 50. That's 70. Definitely way over. And how about 5 and 5? So you have a lot of options with this one. I'm actually going to kind of leave it here for the table, but the idea is you need to be a really adept person when it comes to plugging it in. So now what I'm going to do is I'm going to now go ahead and graph A and B on the grids below. Okay, so what I have is the graph of A, and the graph of A is 2x plus 5y is less than 20, and the graph of B is y is greater than or equal to negative 3x plus 7. So I'll do one at a time. Remember, we got to think about this. We got to be thorough with this. So first I'm going to find the intercepts for this one. So I cover the x, making x 0. The y would be 4. Now I cover the x, make the the y, and make the y 0. I was right. So I cover the x. 5 times 4 is 20. Now I cover the y. 2 times what is 20? That would be 10. So I plot 0, 4, plot 10, 0. And I got to be really careful. Third try's a charm. There we go. Okay, it's as good as I'm going to be able to get it, unfortunately. Sorry, folks. You're gonna have a ruler on the test, all right? I know it's not a nice looking line. Okay? So there's my rough-ish line. Now I choose 0, 0, but I've already shown that 0, 0 is true. That's why we're going to get used to plugging it in, right? Because 0 plus 0 is less than 20. So I just shade below. How about the next one? Y is more than negative 3x plus 7. So I'm starting with 7. This is in slope intercept, so I'm going down 3 over 1, down 3 over 1, down 3 over 1. Okay, graphing it. Okay, putting my test point on. I get 0 is more than or equal to 7. Is that true? No. So in this one, I'm shading above. Nice, that one came out a little bit better. Okay, so again, choosing the test point is the step you do, but you can't do that till you do the boundary line. So first, boundary line, test point, shade. Now this one, if we look at this one, we do need to be careful with regard to the solid or dotted. So notice that this one was an or equal, not an or equal to, so when we do our line, let's just make sure we make it nice and dotted, okay? So maybe that's an excuse for me to try that again. So remember, dotted, solid, solid, dotted, okay? Now I'll go on to the habanero, okay? Now I'm going to go ahead and graph the system of inequalities. So this is, again, I'm going to really encourage you to look at my systems video if this is challenging for you. I'm going to do this in red, and I'm going to do this in black. Okay, so let's do the red graph first. So the red graph is y equals negative 1/2 x plus 1. Okay, that's the boundary line, so I go down 1 over 2, starting at 1. So that's that, down 1 over 2, 1 over 2, 1 over 2, up 1 left 2, up 1 left 2, 1 left 2, 1 left 2, and up 1 left 2. Now I'm going to go ahead and bear with me. Okay, now this is a dotted line because this is not or equal to. Now I choose 0, 0. Is 0 greater than 1? It is not, so I'm going to shade above. Okay, remember on the test, I recommend you try a colored pencil here. Okay, other one, 3x plus 2. So I've got my 2 going up 3 over 1, up 3 over 1, down 3 left 1, down 3 left 1, down 3 left 1, solid line. Okay, choosing 0, 0 again. Is 0 less than or equal to 2? Yes. Okay, observe that my solution region is right here. Okay, all you have to show me is them overlapping. Okay, that's how we do it. All right, last one. Here we go. I'm going to graph this next system. X plus y more than or equal to 1. Y less than 3x plus 2. So first, x plus y equals is greater than or equal to 1. This one's a little bit straightforward insofar as we know both of the intercepts are 1s, rather 0, 1 and 1, 0. Okay, now I connect these. Okay, choose 0, 0. Is 0 more than 1? It is not, so I shade above. Okay, now I'm going to do y is less than or less than 3x plus 2, strictly less than. So I have 2, I've got up 3 over 1, 3 over 1, down 3 left 1, down 3 left 1, 1, 2, 3, 1, 1, 2, 3, 1. Okay, connect it with a dotted line because it's not or equal to. Now is 0 less than 2? It is. So I'll shade on this sign, okay? Again, revealing a very similar, all right, solution region. This one looks kind of weird, but again, I think in this one the grids are a little bit funky, okay? But remember, note that this is where the solutions are. Okay, so again, on the quiz or the test, I'm going to allow you to use colored pencils. Please be extremely, extremely clear where the solutions are. Point to it, write solutions, make it extra dark, but you have to be clear. When in doubt, I'm going to not mark it right because I need you to really push for precision here. All right, so if this was tough for you, go back, go ahead, look through it, all right? And then in a second, I'm going to go ahead and move on to the final section. All right, here we are, finally at last, linear inequalities in context. And I apologize for the slight bleed through here, so we'll try to work around it. Okay, we kind of did this in class, all right? So what we got is we need to match the word with the description. When we see less than, we're going with this. X is less than. When we see more than, we're going with this. No more than means it could be the same or it could be less, okay? No more than 10. It could be 10, it could be 9, it could be 8, it can't be 11, and then at least, okay? So less than is this, more than, no more than, at least, okay? Extremely important. Let's see how we put this into play. So here's an inequality. All we're going to do is write it, okay? Kobe is collecting change to buy a new video game. He only has room for quarters and dimes. A quarter is worth 25 cents and a dime is worth 10 cents. Kobe needs to come up with at least $50. So think about what letters will we use here to represent each. So let's let a D value equal the number of dimes. Let's let the Q equal the number of quarters. Okay, so I need at least $50. How much is a dime worth? A dime is worth 10 cents. So I take 0.1 times the number of dimes, right? So if I have 10 dimes, that'd be $1. If I have 2 dimes, that'd be 20 cents, etc. And I'm going to add that to what the quarters are worth, right? 25 cents per quarter, at least $50, okay? And then I could graph that, right? My intercepts would be, well, it would take a lot of dimes, right? It would take you 500 dimes to get $50, right? Because 10 dimes for 1, okay? Quarters, I would have 200. So in other words, I would have 500 0 and 0, right? 200. So some pretty big x-intercepts there. And finally, writing a system of inequalities, okay? Franklin and Marcus own a lemonade stand. They sell small and large cups of lemonade. They sell a large cup for 2 and a small cup for 1. They need to make at least 30 so they can repay their parents, but can only afford 25 cups. Okay, so notice that I've already given you the constraints. So I need to make at least $30. A small cup is $1. A large cup is $2, and I have to make at least 30 total. And then I have to sell, I can only sell no more than 25 cups. On the quiz or the test, you'd have to take this one step further, of course, and graph it. So you have intercepts of 0, 25, 25, 0. You'd have 30, 0, and 0, 15. You'd shade, you look for the overlapping shaded region. But I thought right now, because of how much we're going to have to really be prepping, that I would have you just write the equations themselves, and then we'll come back strong on the test and actually graph them. All right, so I hope you found this video to be informational. I hope it helped you to answer some questions. You know, keep working at it. This has definitely not been an easy unit, right? It's challenged us. But remember, you got to keep at it. You got to don't let things get you down. You know, when things start to get hard, you know, that's when you want to ask questions. That's when you want to keep pushing. Don't give up, because I'm here for you. I want to help you, but you got to push through it. And remember, you can do it. All right, so keep those questions coming. Don't forget to love math, and have a wonderful day.